Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Building a Simple RL Agent, Making AI Learn to Play a Game. Imagine you want to teach a puppy a new trick. You don't give it a manual. You show it, and when it does something right, you give it a treat. When it does something wrong, maybe a gentle no. This is exactly how reinforcement learning, RL, works for AI. We're going to build a simple AI that learns by trial and error. Just like that puppy. To play a basic game. No complicated math, just logical steps that a developer can understand. For our AI to play a game, it first needs to understand the game's rules and environment. Think of it like this. States. Asterisk, these are all the possible situations or scenes the AI can be in. If it's a simple maze game, a state could be I am at position X, Y on the map. It's like a snapshot of the game at a particular moment. Actions. Asterisk, these are the moves the AI can make from any given state. In our maze, actions could be move up, move down, move left, or move right. As developers, we'll define these states and actions clearly so our AI knows its boundaries and what it can perceive and do. The agent is our AI itself, the brain that learns and makes decisions. In our game, the agent is the character or piece that is trying to win. Its job is simple. Look at the current state of the game, where it is, what's happening, and decide which action to take next. It doesn't start knowing anything. It learns through experience, just like a human player trying a new game for the first time. We write the code that embodies this agent. How does our AI puppy know if it did the trick correctly? It gets a treat. In RL, we use rewards to tell our agent if its actions were good or bad. Positive reward. Asterisk, if the agent makes a move that brings it closer to winning, like reaching a goal or collecting a point, we give it a positive reward, e.g., +1. Negative reward. Penalty. Asterisk, if it makes a bad move, like hitting an obstacle or losing a life, we give it a negative reward, e.g., -1 or -10. The agent's ultimate goal is to maximize the total rewards it gets over time. We, as developers, design this crucial reward system. How does the agent remember what worked and what didn't? It uses something called a Q table. Asterisk, imagine a giant spreadsheet or a developer's lookup table. On one side, you list every possible state of the game. Across the top, you list every possible action. Asterisk, each cell in this table stores a Q value, which is essentially a score representing how good it is to take a specific action from a specific state. Asterisk, when the agent plays, it updates these Q values. If an action leads to a big reward, that Q value goes up. If it leads to a penalty, it goes down. Over many trials, the Q table fills up with the best strategies, guiding the agent's decisions. If our AI only ever chose actions it already knew were good from its Q table, it might miss out on even better, undiscovered strategies. This is exploitation, using what you already know. Asterisk, but if it only tried random new things, exploration, it might never learn an optimal path, even if it stumbled upon good moves by accident. The trick is to balance these. Early on, the AI explores more, trying random moves to fill its Q table. As it gains experience, it exploits more, relying on its learned good moves. We can control this balance with a simple setting, often called epsilon. As developers, here's how we typically structure our RL agent in code. 1. Initialize. Asterisk, create our empty Q table and set up the game environment. 2. Loop for episodes. Asterisk, play the game many times. Each full game is an episode. 3. inside each episode. Asterisk get the current backquote state backquote from the game. Asterisk decide on an backquote action backquote. Either explore randomly or exploit the best known action from the queue table. Asterisk perform the backquote action backquote in the game environment. Asterisk get the backquote new state backquote and the backquote reward backquote from the game. Asterisk update the queue table using the old queue value, the reward, and the queue value of the best action in the backquote new state backquote. Asterisk repeat until the game ends. This loop is the heart of our learning process. While we started with a simple game, the principles of reinforcement learning are incredibly powerful and widely applicable. This same trial and error approach is used in robotics. Asterisk teaching robots to walk, grasp objects, or navigate complex environments. Self-driving cars. Asterisk optimizing driving decisions in real-time traffic scenarios. Resource management. Asterisk making smart decisions in data centers or energy grids to maximize efficiency. You've just taken your first step into a fascinating field where AI learns by doing. Just like us, the skills you learn here are foundational for many cutting-edge AI applications. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.